Myself, Basavara Shivananda Parapnar. My subject is chemistry. In BSc 5th sem, my UCMS number is U02EY23005. My topic is chromatography. Chromatography is one of the most powerful and widely used techniques in chemistry for the separation, identification, and purification of components. Is a mixture. The term chromatography originates from the Greek words chromo, color, and graphene to write, reflecting its early use for separating colored compounds. Among various chromatographic techniques, column chromatography is one of the simplest and most versatile methods extensively used in organic chemistry, biochemistry, and analytic bond laboratories. Column chromatography operates on the principle of differential absorption or partition at component between a stationary phase, liquid or gas. It allows for the both qualitative and quantitative analysis and is particularly suitable for separating and purifying large quantities of substances. Theory of column chromatography. The separation in column chromatography is based on the differential affinities of components towards the stationary and mobile phase. When a mixture dissolved in a suitable solvent is introduced onto the top of the column packed with an absorbent like silica, jet or alumina, each component interact differently with the stationary phase. Components that strongly adsorb to the stationary phase move slowly through the column. Component that weakly absorbs move faster and get eluted earlier. The process depends on two main phenomena. First one, adsorption for solid stationary phase like silica or alumina. Second one, partition for solid stationary phase created stationary phase coated on solid supports. The roll movement of each component through the column depends on nature of stationary phase. Example, polarity, surface and area. Types of solvent. Example, mobile phase. Polarity and molecular size of solvents. Temperature and column dimensions. The overall separation can be understanding using the concept of retention factor RF in planar chromatography, which correlates with illusion volume negative in column chromatography. Types of column chromatography. Chromatography can be classified based on the mechanism of separation. First one, adsorption column chromatography. Second one, partition chromatography. Third one, ion exchange chromatography. Fourth one, gel filtration chromatography. Fifth one, affinity chromatography. In apparatus of materials. A typical column chromatography setup consists of first one, glass column. Example, with stopcock at the bottom. Second, stationary phase. Adsorbent such as silica, gel or alumina. Mobile phase element. Solvent of mixture of solvents. Sample mixtures to be separated. Example, dyes or organic compound. Collection tubes for collecting separated fractions. Technique of column chromatography. The general procedure involves the following steps. A preparation of the column. The glass column is filled with the absorbent silica or gel alumina, either by dry packing or wet stir method. The adsorbent is mixed with solvent to form slurry which is poured into the column ensuring no air bubbles. The column is tapped gently to achieve uniform packing and a flat surface. Application of the sample. The sample mixture dissolved in a small amount of the mobile phase is carefully added on top of the stationary phase without disturbing the column. Illusion. Illusion. The mobile page element is then added continuously. The compound begins to move on the column at different rates according to their interaction with stationary page. Factor affecting separation. Nature of stationary page, polarity and particle size affect resolution. Second one, mobile page polarity. Appropriate solvent selection is essential to polar solvent selection. Cause fast illusion, reducing separation. Third one, column dimension. Longer column improve resolution but increase time. Fourth one, sample size. Overloading can cause poor separation. Fifth one, flow rate. Too high flow rate may reduce contract time and lead to poor separation. Advantages and limitations. Simple and versatile technique can be handle large sample quantities, suitable for colored and colorless compound, provide high purity and efficiency separation. Application of column chromatography. First one, purification of organic and inorganic compounds. Second one, isolation of natural products like plant pigment, alkaloids and essential oils. Third one, separation of amino acids, peptides and proteins in biochemistry analysis of reaction mixture and monitoring synthesis. Industrial applications, pharmaceutical, food and petroleum industries. Sixth one, environmental analysis for detecting pollutants and dyes. Limitations, time consuming process, require carefully solvent selection. Resolution decreases with column overloading or high flow rates. Conclusion, the experiment demonstrates the effectiveness of column chromatography separating compounds with similar structures but different absorption properties. Thank you about it.